A block of mass m is placed on another block of mass 2m, whereas the surface between these two blocks, as well as the surface on which the bigger block is placed, both are not frictionless, both are rough surfaces, whereas the coefficient of kinetic friction is mu. And if you apply a force on a lower block, right? So if you are going to apply the force on the lower block, then the upper block will have a tendency to slip. All right. In which direction? So it can slip in this direction. So in order to avoid this slipping effect, there must be a force of friction that must be exerted in this direction. So this is a force of friction on the upper block applied by the lower block. And why I am saying this, because in this question they say that the both blocks accelerate with with same magnitude. So if they accelerate with same magnitude, it means that the upper block is not accelerating. And students, why it is not accelerating? Let us see this thing in the free body diagram. I'm going to draw the free body diagram of this mass. So this is a mass m on which you can easily see that this is a force applied by the upper block on like a lower block on the upper block, and this is a force applied by the weight of the block, that is mg. So these two forces are balancing each other, but what about this force is not balanced? So this is a frictional force which is equals to mu, and for this case it's a coefficient of static friction because it's not moving, mu normal force. All right, and you know very well that its value should be, because normal force is equals to mg, so mu mg is the amount of the force, is a magnitude of the force which is avoiding any slipping of the upper block on the lower block. Okay, now it's time to find the to draw the free body diagram of this, because in this question you have to find out the force accelerating the smaller mass. Although you can see we had already find the magnitude of the force which is the acceleration of this mass, but can I say this is equals to ma? So now we don't have any idea that what is the magnitude of acceleration. For this we have to draw the free body diagram of the second block. Dear students, this is a mass 2m, and how many forces are exerted on it? First of all, do you remember I told you that this is a force exerted by the lower block on the upper block? And if I consider this is an action force, so according to the Newton's third law, it must have another pair of, like it must have a reaction force which must be same in magnitude but opposite in direction. So this must be mu mg is a force that is exerted on this block, the lower block by the upper block. So this is a one force. And which one is another force? Don't you think the ground is also applying a force on the block? So that is mu 2 mg, whereas you are applying applied force is F, and this must be 3 mg is a weight, the total force downward on this block, whereas you can see that this is a force, a normal force, let's say Fn prime. Okay, anyway, so if you make equation by looking this free body diagram, so can I say that force F minus mu mg plus mu 2 mg or 2 mu mg is equals to the total mass times acceleration? Okay, because this equation will give us the value of acceleration, then we will put this value here to find out the force. Okay students, so this is the net force, and F minus 3 mu mg must be equals to 3 ma, and you can see we have got an equation for acceleration, because in the start I set the same acceleration of the upper and the lower block. So this acceleration is F minus 3 mu mg over 3m. Now it's time to plug the value of acceleration in this equation, which equation you remember I told you that mu mg was the resultant force, net force for the upper block, is equals to ma, and here we are going to put the value of acceleration, so 3 mu mg over 3m. All right, and you may cancel it. All right, and hence we have got f minus f over 3 minus 3 mu mg over 3, and finally the resultant force is in f over 3. So we basically eliminated the acceleration a from this equation because none of the answer have acceleration in the options. This is a reason. So mu mg, so this is a resultant force which is in fact equals to mu mg, so our answer must be option A.